Okay, let's look at question number 7 from the first of the statistics revision quizzes. And it says we're given a failure time of a particular component. It's a y-ball random variable with a parameter shape beta equals 2 and a characteristic life eta equals 5, and determines 2 decimal places the MTTF, mean time to failure. And again, we're given the not so subtle hint that the gamma function of 1.5 is equal to 0.8862. So what do we need to do here? So I can't see the mean time to failure formula for a y-ball distribution where there's just one component spelt out for you. But if you look at equation number 105, the mean time to failure of the system, and then it's got a funny looking thing with -1 over beta in the top. Well, basically this is what we're doing. We're finding the mean time to failure of a system like that, only we don't need to use that ugly expression before the gamma, because that actually cancels out and just becomes eta times the gamma function for 1 plus 1 over beta when you just have the one component. So in this case, that's going to be equal to gamma, so 5 times the gamma function for 1 plus 1 over 2, which is equal to 5 times the gamma function for 1.5, which is 0.8862, and that's going to be equal to 5 times 0.8862, 4.431. 4.431, let's make sure I've got this correct. 4.431. And that's our answer. Very simple one. The other way, I guess, to do this is to find the reliability function. So that the other way you can do it is to find R of t for the y-ball distribution. And remember that, and once you have that, you'll find mean time to failure is equal to the integral from 0 to infinity over R of t, and if you do that, you'll find it's exactly the same thing, remembering that R of t for a y-ball distribution, I think we've used in a couple of these questions already, is an exponential e to the minus t over eta, all raised to the beta. But we don't have to do that because we've got this nice convenient formula just for working out the mean time to failure of a single y-ball distribution fairly simply.